Hi everyone, welcome to my channel Big Bang Chemistry, a complete solution of chemistry. In the series of important topics of chemical bonding, today we are going to discuss the back bonding in trisilylamine. Before going the depth of discussion, let's see some of the important reasoning type question. The first question is that trimethylamine is sp3 hybridized while trisilylamine is sp2 hybridized. The second question is that trimethylamine is a pyramidal but trisilylamine is what? Trigonal planar. Why? The third question is that trimethylamine do not show the resonance but trisilylamine show the resonance, and some other such type of reasoning question you will get. But answer of all such type of question is what? Only and only one: back bonding. So trimethylamine is able to show the what? Back bonding, but trimethylamine is not showing the back bonding. That's why these many variations are going to observe. Now first question is that why trimethylamine will not show the back bonding? So before starting this, we must recall the conditions for the back bonding. Out of all conditions, first condition is that donor atom must contain the what? Lone pair of electron, and acceptor atom must contain the what? Empty orbital, right? And donor atom must belong from second or third period. Even acceptor atom also must belong from second and third period. And rest of the detail, that conditions for the back bonding, I already discussed in the first video of this back bonding introduction part, so you can watch that video also. Now first check that why trimethylamine will not show the back bonding. So for understanding this, draw the Lewis dot structure or a structure of trimethylamine. So let's try to understand first. Trimethylamine will not show the back bonding. Why? If trimethylamine is not showing the back bonding, meaning is that it is not going to follow the conditions for the back bonding. So let's check. In this structure, first check the electronic configuration of nitrogen. Once you will check the electronic configuration of nitrogen, then you will find nitrogen atomic number is 7, configuration is 1s2, 2s2, 2p3. Now nitrogen is having lone pair of electron, which may work as our donor atom, right? Nitrogen is fulfilling the condition for the back bonding. But what about the carbon? Check the carbon atom. Carbon atomic number is 6, configuration is 1s2, 2s2, 2p2. Now carbon don't have the what? Any empty orbital. There is absence of empty orbital. And this is the second condition of the first condition, that the acceptor atom, if this methyl group carbon acting as acceptor atom, it must has the what? One empty p orbital or d orbital. But this carbon don't have any empty orbital. So first condition is not going to fulfill by this trimethylamine. That's why there is no chance of back bonding. If there is no back bonding, meaning is what? This lone pair is not going to use anywhere. That's why trimethylamine do not show the back bonding. Now we are going to understand why trisilylamine will show the back bonding. Back bonding in trisilylamine. So the molecular formula of trisilylamine is NSiH₃ whole 3. Now draw the two structure of this trisilylamine. One for the what? Before back bonding and one for the what? After the back bonding. And during this process, what are the changes going to happen in trisilylamine? Those changes are the reason for the what? Back bonding in trisilylamine. Now check the structure number 1. In this structure, first check the hybridization of each atom. So nitrogen is what? sp3 hybridized, which is what? Central atom. Here silicon is also what? sp3 hybridized with respect to the silicon. What is the meaning of this? This lone pair of electron is present in what? sp3 hybrid orbital. Correct? Now for understanding that, this trisilylamine is forming the back bonding, meaning is what? This trisilylamine is going to fulfill the all conditions for the back bonding. So what is the first important condition? The donor atom must contain the lone pair of electrons. So nitrogen is containing the lone pair of electron. Now check the acceptor atom is containing the vacant orbital or not. So first check. Nitrogen atomic number is 7, 1s2, 2s2, 2p3. So now 2s2, this is 2p3. So now this nitrogen is having what? 3 sigma bond, and this is a lone pair of electron. Now check the silicon. Silicon atomic number is 14. Configuration is 1s2, 2s2, 2p6, 3s2, 3p2. Now with this configuration, this silicon is having 3d vacant orbital, right? Now check the ground state configuration in terms of orbital diagram. This is 3s2, this is 3p2 in ground state, and there is what? 3d empty orbital. When there is excitation of this atom, so one electron will jump to the what? Empty p orbital, and then new configuration of silicon in excited state will be 3s1, and this is what? 3p3. Now again, this silicon is what? sp3 hybridized with vacant d orbital. Meaning is what? In this trisilylamine, silicon is having vacant d orbital and nitrogen is having lone pair of electron in sp3 hybridized orbital. Be careful. Nitrogen is having lone pair of electron in sp3 hybridized orbital. As we know that hybrid orbital always form the sigma bond with the overlapping of other hybrid orbital or pure atomic orbital. And we know that back bonding is having the pi nature. So how the hybrid orbital or the electron present in the hybrid orbital is responsible for the formation of pi bond. For the formation of this back bond, nitrogen should bring this pair of electron into the pure atomic orbital. Then nitrogen can donate this lone pair of electron to the empty d orbital of silicon. Otherwise, this back bonding is not going to form again. So what nitrogen will do now? So try to understand the condition of this trisilylamine during the back bonding formation, or condition of this nitrogen, right, when this nitrogen is going to form the back bonding with the silicon atom of silyl group. So now each silicon atom of silyl group is having the empty d orbital. First show it. This is the empty d orbital. So now each silicon atom with vacant d orbital. This is the vacant d orbital. Now nitrogen want to donate this lone pair of electron to this vacant d orbital, but this lone pair is present in which orbital? sp3 hybrid orbital. Then what nitrogen will do to bring this lone pair of electron in pure atomic orbital? See that configuration of nitrogen. Check, this is the nitrogen atomic number 7. Configuration is 1s2, 2s2, 2p3. So in terms of energy level diagram, it will be easy to understand. This is the 2s2 and this is the 2p3. Because nitrogen knows that if nitrogen form the back bonding with the silicon vacant d orbital, then this full system will be more stable. So for this, nitrogen will bring its lone pair of electron in pure atomic orbital. So what it will do? Nitrogen will undergo one more excitation. And during this excitation, what will happen? One of the s electron will jump to the p orbital, and this s becomes 2s1. So nitrogen atom will undergoes the hybridization with this 1s 2p orbital. So now nitrogen will change its hybridization. It will become sp2, and this pair of electron is present in the now? Pure p orbital. Now this lone pair of electron present in pure p orbital. So nitrogen will easily donate its electron to the vacant d orbital of the silicon. Now check, this is p orbital, this is d orbital. So the nature of back bonding, this back bonding will be p pi d pi back bonding, right? So now in trisilylamine, between nitrogen and silicon, there is multiple bond character. Why? Because nitrogen silicon single bond will be sigma bond, this will be pi bond. So now because of the formation of this p pi d pi bond, and because of the presence of one more additional pi bond, what will happen? The pyramidal shape of the trisilylamine will open and becomes total trigonal planar, because of the formation of this p pi d pi back bonding. So now what is the final structure of this trisilylamine? Now this is the final structure of trisilylamine. In this structure, this is the sigma bond, sigma bond, sigma bond. This is the pi bond, pi bond, pi bond. As we already discussed in the first video that if central atom will be the donor atom, then geometry of the molecule will change. Now compare this structure with this structure. This is the structure of trisilylamine before back bonding, and this is the structure of trisilylamine after back bonding. So what is the difference between these two structures? Difference is that before back bonding, this lone pair was in sp3 hybrid orbital. That's why nitrogen was the sp3 hybridized. That's why it seems like the word pyramidal. But experimentally, when it was checked, then trisilylamine was trigonal planar. Now what happened? This nitrogen steric number is what? What is the steric number for this nitrogen? Only sigma bond 3. That's why hybridization is sp2, and geometry will change trigonal planar. But here, what was the steric number of nitrogen? Sigma bond plus lone pair of electron, 3 plus 1. There is a 4, right? So now, after understanding the back bonding in trisilylamine, again go through the answer of all the questions. Now we can easily give the answer of all the questions which I started in the beginning of this video. Now check, trimethylamine is sp3 hybridized. Why? Because of the absence of back bonding. While trisilylamine is sp2 hybridized. Why? Because of the presence of back bonding. Trimethylamine is pyramidal. Why? Because of the absence of back bonding. Trisilylamine is planar or trigonal planar because of the presence of back bonding. Trimethylamine do not show the resonance, but trisilylamine show the resonance. So where there is a pi bond, there will be delocalization. So what is the resonating structure of this trisilylamine? We can show the partial bond character between nitrogen and silicon atom of silyl group, because this pi electron will be continuously delocalization, right? And continuous delocalization will generate the resonating structure. When there is a resonating structure, then there is a resonance hybrid. So what is the structure of this trisilylamine, we can show this partial multiple bond character by broken line. So I hope that everyone is understanding the back bonding in trisilylamine. For such type of interesting discussions and more videos, please like, share and subscribe my channel. Thank you very much.